we learned about what hash is.
Yeah.
And from what I recall, hash just makes sure that everything you claim hash on follows a certain interface, and it keeps that same interface through a string, like through a if there's there's an array of different objects. Am I wrong? I'm just kind of going up. I don't really.
Yeah,
I'm
yeah,
just
yeah.
trying to
I mean, I
here.
think you know what you're saying, but
I mean, kind
you
of.
aren't familiar with the terminology.
So here, this is my like best guess is
Yeah.
a hash. Okay, you create a hash, and we put like I sigma node or something in it, and then
And
everything.
what do you mean by in it?
Okay.
Do you mean
so we
as
put
the type argument as t?
yeah as
Okay.
t.
Yeah.
And then so this is the type as the type argument, and then with underneath, so within this hash, which is between these brackets,
Yeah.
we have a string, and it was in this. Well, no, we had an array here.
So that those brackets that actually doesn't stand for array.
Okay, I thought we had like an array of, and then there was objects that were created.
Right.
There was an array of objects that all conformed.
The correct terminology is not array. It's actually an object with a bunch of properties, and the value of each property is an object that conforms to type T.
Yeah. Okay.
Can you say it again?
So you say it again. You say it again.
The hash is an object.
Hash is an object.
It contains a bunch of key value pairs. Key is a synonym for property. So it contains a bunch of property value pairs. And each property must be of type string.
Yeah.
That's what the left side of line 185 says.
Okay.
And then the right side says that the value must be of type T.
Okay. So you meant 1105, right? You said 1105?
Yeah, 1105, yeah.
Yeah, okay. So hash, this is an object.
Well, it defines an interface.
Okay, it defines an interface.
Objects can conform to.
Yes, okay. It defines an interface that objects can conform to.
Yes.
And that is T?
The value of each property in the object must conform to type T.
Okay.
The object as a whole conforms to type I hash T.
Okay. And so all of the objects within the... Okay, so say that again. I hash is what?
Defines an interface.
Defines the interface.
Any object that conforms to the interface.
Yes.
Has a bunch of key value pairs. And each key must be of type string.
Yes.
And each value must be of type T.
Okay. And then type T is... What is type T?
It's whatever you pass inside the brackets as the type argument. So if we say...
Okay, so T is right here, is this?
Yes. Well, yeah.
This.
No, T is literally the letter T.
No, I know.
Here.
I know. And so type T, the type is whatever we pass in the brackets. Is that what you just said?
In the less than greater than sign.
Yeah, okay. Now, this is just the name of it. Okay, then. Right?
The name
this
of
is just T.
It's the name of the type that all our values of the key value pairs must be.
Yes. Okay. And there's nothing more. Like, is there another place where we would have T? Like, if I go like this, is there somewhere where T is? Or
no, but it's just defined as the type of each value in the key value pairs.
Yes. Okay. So there's, And ID string, what is this? Is
so that's a weird syntax, which essentially says that temporarily we're naming each key in the key value pair. We're naming it ID, and we're saying that this temporary variable called ID must be of type string.
Yeah. Okay.
So essentially, saying that the key must be of type string.
Yeah.
Or else it'll throw an error.
Yeah. Yeah. Okay. Okay. And then, so this is the interface I hash right here. Then
Yes.
This whole thing. Okay. And so is this? I'm sorry that I'm keep asking
Keep
this.
asking until you understand.
Yes.
I'm fine if this takes 20 minutes.
Okay. So iHash is the interface.
Yes.
Now T is the type that all what?
That all the values.
All values must.
Of the key value pairs.
Okay, and
must
key
have.
value pairs are like ID.
So let's say we have.
Like what's the three over here? Is it content ID, parent and children? Are those type or are those pairs or whatever? Are those value pairs?
Those are the these are the keys.
Okay. Can you just give me an
Yeah,
example of a value pair?
All right. So yeah.
What's a just like write a previous example that I might have seen as that's a value.
The key.
Okay.
This would be the value.
Yeah. Now, and all three of them together are a value pair? Or all two of them? What's a value pair?
Alright, this is the key.
Yeah.
This is the value.
Yeah, okay.
This value itself is another object.
Mm-hmm.
Every object is composed of key value pairs. Another way to say it is composed of property value pairs. So we have an object right here, which is the value of this key. This object itself has two key value pairs.
Mm-hmm.
Height is one key, 70 is the value for height. Weight is one key.
Okay, so value pairs is height and 70 are a value pair.
Yes.
Okay.
Alright. Yeah.
Nice. Okay, so T is the type that each value pair must be.
Yes. So here, now we'll type T is the type that the value of the key value pair must be.
And 70 is the value of height.
Yes. And the object with the two properties, height and weight, this is the value of the key John.
Yes, okay.
And if you look.
And John with that, okay, so John and those two things you circled, that's a value pair.
A key value pair.
Key value pair.
Yes.
Okay.
This is the key, this is the value.
And then height is a key?
Yes, height is a key.
And 70 is a value.
Yes, exactly.
And that's a key value pair.
Yes.
Nice.
Key value pair inside of the value.
Yeah. And you can just do that forever, I guess.
Now, let's add another key value in here. Height, we're going to say you're like 7 foot, so 84 inches. And your weight. I don't know how heavy a self-person would be. Yeah. So RJ is what? What would we
It's
call
a
it?
key.
It's a key, yeah.
And
Also
then-
known as a property.
Yes.
And then the value associated with RJ key
Is height. It was everything in those brackets.
it's an object,
An object
which itself
has key value, has two keys and two key value pairs.
exactly.
Okay.
So another word for object is actually hash.
Okay. Okay.
So in programming in general, when people say hash, in JavaScript, hash and object are interchangeable.
Yeah. Okay.
But more specifically, we created an interface called iHash, where we specify that the values in the key value pairs must be of a specific type. We created the interface ourselves and gave it the name iHash.
Okay.
Now notice how these values in the key value pairs are of type iPerson.
Yeah.
iPerson itself, well, it's some interface that says you must have two properties of height
Yeah.
and weight, and height and weight are each of type number.
Okay. And so T is the type.
Yes. So what is T in this
That-
case?
T is the type that the value pairs
That
must.
the value of the key value pair must conform to.
Okay, just the value of the key value pair. Okay, this whole thing's an object, and then is ID the value?
ID is just a temporary name for the string. So
Yeah.
we're temporarily calling each key. Sorry, temporary name for the key. So we're temporarily calling each key ID.
Yeah.
And we're telling TypeScript that ID must conform to type string.
Okay. Yeah.
And the
ID
way
must
you
be
do
a
that-
string, and then this value must be of type T.
Yes, exactly.
ID must be of type string, and then therefore that string is of type T.
The string is not of type T. The value associated with that key, which is of type string, that value must be of type T.
Yes. Yes. Well, since that value is of type string.
Value is not of type string. The key, which we're giving a temporary name of ID,
is of type string.
Yes.
Okay. And then the ID. So within this bracket,
Yes.
wouldn't it just be the actual ID?
What is it?
Okay, so it would be ID. I see. So like, it would be. Okay, hold on. So I'm just gonna type it and like comment it out. Yeah. Okay. So this is like saying, okay, so ID type T, but then you just take.
No, we're not saying ID is of type T. We're saying that ID is of type string.
Okay, what is this in the bracket? This is the actual value.
The ID is a temporary name for the key.
Mm-hmm.
And we're typing ID to have type string.
And so this key, does this key need to be of type T?
No, the key needs to be of type string.
And then the value needs to be of type.
The value needs to be of type T.
Okay, so I'm confused at how the syntax means that.
Weird syntax. All right, so
you know what I'm saying?
So normally,
like it's just assumed that this is now the ID is like the value is put in there. Like this is a value then.
Yes. All right. So our normal interface syntax is good question. Shows you paying attention. We have like a property name, right?
Yeah.
And then we have our type. So we could say if we had, okay, let's say we had a property name that property name was height.
Yeah.
We could say height must be of type number.
You know, the syntax is weird, just that it assumes ID : string is equal to a key. That's weird to me.
That's just how it's defined. I don't know why it's like that. I think it's weird syntax too.
So like, for me, the way intuitively it would be, instead of this, it would be
maybe like string.
ID would be of type string, and then this would be like, since this is the key, this would be the value, and then this all of that would then be type T. Well, wait, no. So we have John and then height. Hold on. Okay, so let me just do it this way. John. Okay. So if I do John : then I do this height. Right? Okay. Is that right?
Well, that is correct for creating an object that conforms to the interface. But here we're creating the interface definition.
Yeah.
So we wouldn't be able to type that inside the interface.
No, I know. Okay, so this is just I'm bringing it down to my level.
Yeah.
So that I can try to explain what I'm.
Yeah.
Okay.
Yeah.
So what am I trying to say? So the value needs to be of type T, right?
The value of the key value pair must be type T.
This is a key value pair.
Yes.
This is the value of the key value pair.
Like, and make sure you have the brackets inside of your selection. Because the bracket.
Yes.
Yeah. So all of that is the value.
Is the value. Okay. Now.
So what we're saying.
Okay.
What the bracket ID : string says is that.
Oh, I get it now.
We're going to have some ID, some string. We're going to temporarily name it the variable ID, and that variable must be a type string. So John was not a type string; it would have thrown error.
John should be a string.
Yeah.
So would it actually be like this?
Theoretically, yes, but TypeScript lets you omit the quotes if it is a string.
So
if you type 54 though, it would error out.
Yeah.
54 without quotes.
Okay. Now, what I was confused about is that they're assuming this is key.
Yes.
And this is value.
Exactly.
This is key.
Exactly.
And this is value.
Exactly. So
that's what I was confused about.
The syntax is weird because they needed some way to figure out how to type the key.
Yeah.
So they came up with saying we're like, all right, we'll put a key
Yeah.
value pair for the key inside of brackets.
Mm-hmm. Because I was only thinking before. I was thinking value.
Right.
Or no, key value, and then key, and then value. But this whole thing is the value.
Right.
I just needed like
That's good that you put them side by
a
side.
simple analogy.
Yeah.
Now I get it. You know what I'm saying?
Yeah.
Okay. So sorry for that tangent, but no.
It's good that you're learning stuff because we're making a learning company.
Yeah.
And I'm thinking like, this would be so hard to do. How would we make a computer system that could have figured out what your thought process was going to be?
Mm-hmm.
Figured out that you would have needed that example to understand.
Yeah, it's like whatever. We shouldn't think of a name for like. This is just like a generic version. This is like basically this syntax. Okay, the syntax of interface. Well, I'll just do it on here. It's easier. So like this would be the kind of the meta version where you're basically you're wrapping functions, and it's just a generic function that will be used for will be hundreds of thousands of IDs, things like that. But like we need like basically like a dumbed down, just a use case, I guess, where it's like ID would be John. No. It would be ID, right? Then it would be John.
Well, John is not a type, but after the colon, it's expecting a type.
Okay.
So we put string.
So John would have to be type string.
Yeah.
And this would be like height.
Exactly.
Something. So I guess this is like a generic example.
Yes, but yeah, that's example. Yeah.
That's what I was kind of confused about. Because you know what I'm saying? Okay.
Right.
So something for that. So what you're saying, if the computer could just provide me an example of that.
I mean, if we're creating branches and we want to teach people that concept, like you came up with your own analogy. You figured out what you were missing. You figured out that you needed an analogy.
Yeah.
In a textbook, and even a tutor, I couldn't even figure out what you were trying to figure out.
Yeah. Well, I could. I just knew from what you showed me, just the examples that we've used, because we used height and weight for like every example.
Yeah.
I think just plug and play, maybe. You know what I'm saying? When someone sees an algebraic equation, they get very scared.
Exactly.
But once you put numbers in, they're like, oh, the letters just represent that it could be any number.
Yeah.
Once they get that, it's like, oh, okay, it's not that hard.
All right, so
anyways,
you, I think, understand what an iHash is now? What
okay.
interface iHash is?
Now an iHash. Explain to me what iHash is.
It's an interface.
Yes.
That says that any object, such as this object O, that conforms to that interface, must have a key. All the keys must be type string, and all the values associated with those keys must be type T.
Yeah. Okay. And yes. Okay. That's good. I understand what it does. I don't understand why the syntax is the way it is, but that's okay.
The way types were divided to be.
Like this is saying the interface iHash, the values have to be of type T.
Yes. Right
here. And then okay, so then you have your key,
which must be of type string.
And you have your value.
Yes.
Okay. Yeah. Okay. Now here, I guess this is a whole nother ball game right here.
Yeah,
Getting
so here
set.
We're defining a method. Let's look at the get method. So we're defining a method called get. It takes one parameter,
which is a key.
Well,
ID isn't a key?
No. It's a parameter for a method.
Okay, that's fine. So it's a parameter.
We're temporarily calling that parameter ID.
Yeah.
We're saying that parameter must have the type string.
Yes.
And then the get method as a whole, what the colon means after the parentheses of the method, what that means is whatever follows a colon will be the return type of the
Okay.
function. So what we say is that the get method returns the type of T array.
Uh-huh.
Are you familiar
Okay.
with the concept of returning?
Just spits out, or no?
Yeah, so let's say we have a function called f of x, and f of x is defined bx squared. F of 3 returns 9.
Yeah. It's the product, or whatever, or the result. Yes,
So,
returns. No, I get that.
Yeah,
So it's
that-
just, since it's a method here, this is a method.
yes,
And since it's a method, it's yellow.
yes, that's how Visual Studio does it.
And when there's a colon after that, that's what it should return. But since for here, this is a key value pair,
Yes.
but this is a method with what it should return.
Yes.
Cool. All right. So I understand what a hash is. A hash is an interface that a hash is an interface that makes sure the key value pair is of the right type.
Yes.
Both the key and the value of the key value pair are of the correct type.
Yes, and what have we defined the key type to be?
The key is of type string.
Exactly.
Yeah.
And then the value, its type is dynamic.
Is
Its
T.
type is T, whatever T is.
Okay. And so T can change then.
Exactly. We could pass in.
Okay, so
We could
T's.
pass an I person for T.
Mm-hmm.
We could pass an I car for T.
Yeah.
Pass
Okay.
whatever we want.
Okay. So T, and then somewhere wherever you would set like person equal to T or something. Or this is basically, yeah, this interface can be used for multiple different interfaces. You put an interface in for T then?
Exactly. Yes. But
Okay.
You put a type. Remember, types can be either classes, interfaces,
Yes.
or enums.
Yes.
Or what we call simple types, string, number, and array. Those are simple types.
Yes. Oh, so a type can be a lot of things.
Yeah.
A type is like a verb, or maybe not a verb, but a type could be.
Such an abstract concept.
A type is just a word. It's just like, it's a type.
Yeah, I don't know how to describe a type. I don't think it's a type.
How do you describe a
We've
type?
reached the epitome of abstractness.
Let's Google it. What is a type in?
So JavaScript doesn't really have types. But,
Oh, TypeScript, you mean?
yeah. If you want to learn about it, you can later. I say we do some pair coding.
No, I know. I just want to see what the actual.
It's not going to let me do it.
God damn it. Ohio State. We pay all this money, and your internet is poop.
JavaScript does have types, but they're kind of different from the concept of types and TypeScript.
Okay.
Boolean is another
Sorry.
type.
All right. This is the last search I'll do.
Google doesn't even understand.
Yeah, that's okay. Very good. Okay, that's a question for the future. What is a type? What am I? Who
Yeah.
am I? What is the meaning of life?
Yeah.
Those are the
What
same
is the meaning
question.
of meaning?
Okay. So this is what I put.
Nice.
And then this guy was like, I don't want all that. Anyways, okay. Oh, here, this is anatomy. And then it looks a little intimidating, but I'm just going to leave it. I made everything. So what was interesting about the class was I made everything the teacher said into a question that I could study later.
Exactly.
So I'm just building my study material while I'm in class, thinking about the end in mind, you know?
Yeah.
Thinking about the test.
That's how it should be.
Yeah. That's how people should take notes.
Yes.
Is you take notes so that you could just study them. But
right. I can get Rex, and I'm gonna fill up my entire anatomy with green. Where's anatomy?
You're gonna what?
Where's it? That's gonna study that. Is that
Oh, okay.
Is that under the global map?
Yeah, and then it's all the way in the top right. Dude, I'm sorry. I reorganized these before they were all loaded, and everything
it's
is
really the programmer's fault.
fucked.
Because
But I could straighten it out at one point.
Yeah, we'll make that as a future feature.
Oh my god.
We'll update all. What was I gonna say? Oh yeah, by the way, the way the app currently works is my northwest might not be your northwest. If one of us rotates it, it keeps the map rotated for that person.
Oh, how do you rotate?
You do it on
a touchscreen?
Yeah.
Okay.
Now that I'm not on touchscreen anymore, I can't rotate it back.
Uh-huh.
I know, it's a different spot.
Okay, so here, mine's between...
Oh, no, ours are the same spot. Sorry. Maybe
it looks way cooler on the big board.
Alright.
There was the dude was looking over my shoulder in class, too.
What is Prof's favorite bone?
Yeah, dude, this is tight.
Something about that, though.
Because it's just fundamentally something that they've never seen before.
Oh, yeah. Alright. So, smooth triangle.
Even though it just looks funny, there's just something that feels right. Okay. There. Did your computer, do you have to do your dev stuff?
I was going to send something to Patrick by 11.
Okay.
And I texted him, so it's good.
Okay.
Alright, smooth triangle surface on the bottom posterior part of the femur. That is,
Oh, wait.
Top.
No, I don't know it.
We need to make a flip feature where...
That's what I was thinking, too, because the answer's there. But for now, you can just block it. The value that's provided is that these note cards are already created. And the time interval is key, and then a mind map.
Alright.
But
What is a condyle?
Did you take anatomy?
I never took anatomy. What is a condyle?
Yeah.
An oval round projection that has...
For some reason, I can't click right now.
Oh, okay. Town balls at the... Why do you call them town balls? You mean the round balls? Or is it literally called town balls?
No, it's probably a typo. I was going very fast.
Yeah, alright, cool.
I meant to.
So it's an oval round projection. It's an oval round projection that has a smooth surface. So yeah, the round balls are... So that's a condyle. Now know that. What's a condyle? Ball. Yeah, smooth round ball. Yeah. Round ball. Cool. Ooh, nice of you time. Alright, man, look at that. I already have 3 green things.
Hell yeah, dude! And I forgot about how they get bigger the more you know them. I forgot about that. But when I was showing people yesterday, I was gonna say something. So the whole mind mapping, it's not as good at this point because the note cards kind of like get cluttered, but the categories, it really, where the mind map comes in is the categories, not the individual question. You know what I'm saying? So it could be like here.
That's a good observation.
So here it could be, if you do a category, it actually automatically sets it farther apart and a bigger font. Because from here, you would have, right now the mind map would consist of anatomy, and then it would be September 5th.
Right.
This is the coxal or hip bone, okay?
Yes.
This would be thigh bone, and then furthermore, what is this?
Yeah.
Femur, okay. And there's other thigh bones that we'll go into, I think.
Right.
But, you know what I'm saying? The categories matter for mind mapping. Then you zoom in and it's all the questions, maybe.
Yeah.
Or you could hide
the
note cards, and it would just be a mind map.
Yeah.
And then the note cards are just a layer on top of it.
Yeah. You can like toggle off.
Yeah,
What it shows.
a few people have told me two people have told me the concept of layering, which is you
Yes.
either you have your notes and you take green, you highlight all of the categories, femur, or you go thigh bone, hip bone, arm bone, and then the next one would be specific name of that.
Yeah.
And you layer, and if someone else had a different strategy of layering. And oh, dude, Top Hat now? Have you used it lately?
Top Hat, what's that?
You don't know what Top Hat is?
No, never heard of it.
Have you ever taken a class at Ohio State University?
Not for like a year and a half.
Okay, so Top Hat is just. Have you ever used software in class where the teacher puts the questions in, everyone logs in and hits the answers, and it automatically records
Yeah,
it?
I think I've actually used it before.
Jeeves or whatever. What would you say?
I think I've used something like this before.
Yeah, I'll show
It might
you.
have been Top Hat. Yeah.
Yeah. Okay, but on it, so instead of just Q&A, ABC, he put a molecule, and he asked where the hydroxyl group was in biology.
Yeah.
And they would so if I'm hydroxyl, I'll just go.
It would show where everyone was selecting in real time or something?
Yeah, so here, let me think of glucose molecule.
Yeah.
It would ask where the hydroxyl group was.
Yeah.
Okay. And it created a heat map. Everyone clicked where they thought. So one person would click here, click here, click here, click, and it showed a heat map.
Yeah. That's pretty cool.
Yeah. So that was cool. So I don't know how we use that.
Hydroxyl OH?
Yeah. How?
Was it COH? No, carboxyl.
Hydroxyl
is OH.
If I was on a test, I would confidently say it was OH, but I don't want to go on the record and
OH
say.
Oh, yeah, it's OH.
Yeah, OH.
Alright, cool.
Back to pair coding.
Alright.
So that has changed since I took a class last semester.
Interesting.
I have lab at 5:30 today. That's it. Should I give him a time? Should I say to Patrick, or should I just wait till I just actually send it? I could give myself a time. We'll send. Where is he? We'll send poster by 1.
Yeah.
Should I say that, or should I just leave it?
Well, only if you can commit to the time. He's like no nonsense. Like you say something, you gotta make sure it's done by that.
Yeah. Well, we'll pair code till 12, and then I'll work on that. How would you say he is in relation to you? Just a fellow entrepreneur or like a mentor?
Fellow
or in between?
Who is better than me.
Okay, but in between.
He's making more money and he's better than me.
But that's also good that you think he's better than you, because I think you're better than me, and you like if you assume someone's better than you, then you'll kind of like suck their knowledge.
Yeah.
You know what I'm saying?
Yeah.
Not that I secretly think that I'm better than you, and I'm just doing that as a mind trick. This isn't psychological warfare. I promise.
Or is it?
Or is it? Okay.
So we kind of know what iHash is and why we were using that. That was to explain what types That was to explain what iSigma nodes was. So let's Control F in this file.
Okay.
To iSigma nodes. Yeah, so I had to pass the project off to Patrick without finishing it. So I don't even know if I'm going to need 1.5K.
Ah, cool. Why not? Because you just didn't have time?
Yeah, we ran into a bug, and I think I know how to fix it. It could take anywhere between an hour and 4 hours to fix. I just don't have the time. So. And he needs it done by Friday, so I don't know if he should do it.
Did he do it himself?
Well, he's about to.
I wonder how much his client was paying. Okay. Would you like some? Just as much as you'd like. You can just suck it off there if you want. You can just suck it off. It's good. Get more if you want. But now it's all over your fingers. It's going to get all over your computer.
Yeah. All right, so let's look for type I sigma node.
This is brain food. Straight to the dome.
Yeah.
From the bosom of Mother Earth. Okay.
So yeah.
Enter.
Yeah. There we nope, not that one. Not that one. There we go. So look at 17787.
Mm-hmm.
So what does that tell you?
Okay, so the type I sigma nodes is equal to the hash, the interface I hash, which
with a specific
with
value of t.
Yes, which wants the value of t. So is this the same I hash that we just made?
Exactly.
Oh, okay. So
if
I
you were
hash
using that
t.
interface-
So sigma node is t right now.
Yes, exactly.
Okay. And I sigma nodes wants the interface. Okay. Is the hash, and its value is t. Okay. I get what this says, but I don't get why we want it to be this.
We want some object that is, we want to create some object such that all the values of the key value pairs in that object are of type sigma node.
Mm-hmm.
Otherwise, we want TypeScript thrown error.
Yeah.
And the reason we're creating that object is because we're using an object with that type, and we want TypeScript thrown error if we pass incorrect values into that type.
Mm-hmm. And this is right where this is defining a interface, right?
We're defining a type, and we're literally saying a type equal to another interface with a specific value of t.
Now, when we created, do you mind if I? Oh, okay, right. Okay, I want to kind of go where this is for a sec.
That's where we're defining it.
Oh, this is where it is. Yeah. Okay, this is like as deep as it gets. This is okay. Because I remember we made an interface before and it kind of was more like this.
Right.
But that's okay. So I'm now understanding that an interface could be either something like this. Right?
Yeah, well, I sigma node's not an interface.
It's just a type. Because I thought I meant interface.
You're right. I probably shouldn't have used that naming convention. You're right.
What is the naming convention?
Usually, interfaces should start with an I.
Okay.
But I sigma node.
This isn't an actual interface. It's just a type.
Technically, it's not, but it functionally is. I mean, interfaces and all types are kind of interchangeable.
Yeah. Yeah. Okay. That's cool. No.
One the other.
Yeah. Well, yeah. Type.
Well, when you code it, you gotta make sure you have the right name.
Yeah. Yeah. I'm trying to think of what type, an analogy for type.
I'm not sure. We might be getting too far in the weeds.
Yes. No, I agree.
Yeah.
Okay. So I understand that this is a type now, and it equals that hash that we just created, and this is t.
Right. So any object that conforms to the I sigma nodes type, what must that object look like?
It must have a key, and the key must be a string. It should
More
be
specific, you have tons of keys, and each key must be a type string.
Okay. And then the value in the key value pair must be of type sigma node.
Exactly. That was perfect.
Now this is type I sigma node.
Right.
And so I sigma node and sigma node are different, correct?
Right.
Okay.
Because I sigma nodes is a collection, it's a hash of I sigma node, of type I sigma node.
Okay, and I sigma node is class. I sigma node is a class.
Yes.
And it can have all of these.
I sigma node is an interface.
This is an interface right here.
Well, no. So
okay, I went to the wrong place.
Node is the interface.
Okay.
I sigma node is a class that implements that interface.
Cool. And all this. Okay. Cool. I'm connecting dots. I don't know if it's just me having slept well or me understanding more.
Are you familiar with myelination?
Mm-mm.
Should have you read the talent code. It's on one of my audibles.
Talent code?
Yeah, talent code.
Okay.
Talks
I need
all
to
about
finish flow
Yeah.
shit. But
do you do audiobooks or just?
Yeah.
Okay. Yeah.
I think
literally every
audiobooks are
time
better.
When I walk to the restroom, I'm listening to audiobooks.
Okay.
If I have headphones on.
Okay.
I probably listen to
Okay.
2-3 hours a day.
I'm always on the fence of being present and taking in the information. You know what I'm saying? Of like visual.
It's a trade-off for sure.
Also that. So there's a balance.
Yeah.
You're very familiar with quantum mind?
No.
It's where it's like entangled. Two ideas are entangled. Like for every question or any situation, there's most of the time there's two answers or ideas. 2 + 2 = 4. Okay.
Right.
Not, but you know what I'm saying? One is being present. 2 is listening to audiobooks and getting smarter. So there's two. You know what I'm saying?
Yeah.
It's like but there's also a balance.
Yeah.
Quantum is it's like just a. But what is myelination or whatever?
So, have you taken like a neuroscience course or something?
I wanted to. That was one of the classes I was going to audit, but
Alright,
we don't have time.
You know, inside of your brain, you have neurons.
Yeah.
And these neurons, they talk to other neurons
Mm-hmm.
through, I think these are synapses.
Oh, is myelination when they put that substance around the what's the connection called? That line you drew.
I think this is called synapse.
Myelination is when you put something around it so that the electrical current can flow faster.
Right. So
Yeah.
you have these things called nodes of RenDR,
Mhm.
which are like the connections. They're like the electrical signal jumps from one node to the other, to the other, to the other. And what myelination does is it wraps all this in things called sheaths. And those sheaths, I forget physics, they increase the conductance, which decreases the resistance, which increases the speed at which electrical signal can go through.
Mm-hmm.
So like if you were like practicing piano or violin or something,
Yeah.
and at first you're like trying like a new piece, you're trying some new phrase, you'll just like make mistakes because like your brain, one, doesn't have the circuit formed, and two, the circuit's real slow. You practice it like 500 times, the circuit comes really fast, you can do it eyes closed while talking to someone else, and that's all because of myelination. So
now I'm like, we could build that into branches. We could like have the branches get thicker.
Yeah.
So like when you study something, it would immediately go to something else because just as like if you were to try to say the Star Spangled Banner, you'd probably have to start over. Oh, say, can you see? So if you learn something, you have to start at the beginning. You know what I'm saying? And then if I get stopped in the middle of learning, I don't know where I learned this. There's an example about a caterpillar. So if I'm saying that and I get stopped in the middle, I'll probably have to start over.
Right.
Because it's kind of a chain,
Yes.
And it's probably that. Just as a caterpillar, if it's making a cocoon and you stop it at its cocoon at 3 and you put it in another one that's at stage 3, it will just keep going.
Yeah.
But if you stop it at stage 3 and you put it at stage 6, it'll just like not know what to do.
I run into that all the time for practicing piano.
Really?
Yeah.
So we could build that into branches. Like if you know this part about anatomy, it would be like chain. It would be a chain of ideas. So the program, the more you maybe get those in, I don't know how the computer would do it, but that is cool.
Right. So what I was getting at is that I this might be borderline pseudoscience because I don't actually understand what's going on. But let's say there's some circuit in your brain that represents the concept of eye hashes or whatever you're looking at. Maybe overnight I've got myelinated more.
Yeah. Well, I wonder if myelination happens while you're learning or while you're sleeping.
It's both.
Yeah. That's cool. Yeah, man. See, I wanted to take this there's cognitive and behavioral neuroscience, and I wanted to take them both, but I was going to take behavioral, but it's like we have so much to do. It's like, learning is like addicting. You know what I'm saying?
Yes.
Like you can learn all day long and be happy.
The thing is, for lots of people, it's not addicting. I think it's because they don't get in the state of flow.
Yeah, learning's addicting to me, but I just learn, and then I don't do anything with it. So, like, this is me doing stuff with it.
Exactly.
So there's probably like an 80-20 for that, like 20% learning, 80% doing or something.
Yeah.
Okay, so we were talking about hash. Then we got into myelination. So
So let's say this
sigma nodes. Save this file. We didn't change
We
anything.
did. Scroll up. See those green lines? 774. We created a interface called iSigmaNodes Remover.
Yes. Okay. And we did handle update. We just did that yesterday.
Yeah.
Okay.
All right. So we were inside of SigmaNodes Remover. .ts.
Control tab. Oh, fuck. Okay. Wait. Sigma node remover.
Yes. And all right. So notice how scroll to the top, like line 30 or something. Yeah, line 38. Notice how SigmaNodes is of type iSigmaNodes. Well, we know type iSigmaNodes is what?
Is a hash with a hash that, I don't know the terminology. I know that it's hash in the middle is T and that sigma node is T.
Exactly.
But I don't know how to say it.
Right. So we can say it's a hash of type iSigmaNode.
Okay, so I sigma nodes is a hash of sigma node. Of I sigma node.
Yeah.
And then it would be I sigma nodes equals I hash, and then these are brackets. What are these?
Angle brackets.
Angle brackets. And then sigma node is in there.
Yeah.
And that means that the key should be of type, in this specific case for this hash, the key should be of type string, and then the value should be sigma node.
Exactly.
And then when we go to sigma node, it was that whole list of things. It's an object. The value is an object.
Yes.
Cool.
Yeah. All right. So
Okay, sorry.
what we're getting at is if you scroll back down to line 100 or wherever we were, 105, we are trying to access one specific node from this SigmaNodes hash.
Okay.
So SigmaNodes hash
This.
is going to have a bunch of properties, a bunch of keys. What's the type of each of those keys?
So the I sigma node hash
Yes.
is going to have a bunch of keys, and they are going to be of type. Would they be of type sigma node? Are those the keys or
keys?
The keys? Okay, so those are just strings.
Yeah, exactly.
Okay.
So essentially what the interface is telling us is if we want to access a specific sigma node from the this.sigmanodes I hash, we can say if we had the key name, let's say the key name was RJ, we could do this.sigmanodes.rj, and that'll get RJ sigma node.
Dot RJ?
Yes, but the thing is,
it wouldn't be RJ.sigmanodes?
no, it would be this.sigmanodes.rj.
Okay.
And the reason for that is we hit on this yesterday.
You can erase all that crap.
Yeah, if we have an object O, we can access the properties on O in two different ways.
Throw it in the garbage.
So we could do O.John, and that would return this value. We could do O.RJ, and that would return this value.
What is the double slash? Isn't that comment?
That's a comment.
Okay.
I was going to start writing out the value, and I realized I have to write a lot.
No, that's okay. Yeah. I get it, because you just do O.John, and it wouldn't show. It would just show.
Yeah. So what we need to do is inside of our update object, the parameter on line 104. That parameter, what properties is that parameter going to have? Update. It itself is an object with three properties, 3 keys.
Type ID and val.
Exactly.
You.
So let's command click on that interface.
Okay.
And let's look at the type of ID of the property ID.
Okay, so the property ID, we're up here,
Yeah. So
and that is of type ID.
Yeah. So we have a type code ID.
Okay.
So curious, what is type ID? Is it a number? Is it a string? Is it a Boolean? Is it some other complex type?
It could be any.
Oh, it's any. I thought it was string, but I guess it's any.
Okay.
All
Wait.
right. Well, let's just pretend it's Let's just pretend it says string, just for argument's sake. Where's sigma nodes remover?
Okay, that's where we were.
Yeah.
Yeah. Okay.
I might later if you change that type to.
So then we were.
Anyway, so what it's getting at is update. It's going to contain a property called ID, and that update.id property, it's actually going to be of type string. I know it says it's type any, but the way
that's what string isn't of type any. Right? Is it any?
Yeah. So it won't throw an error on us.
Yeah.
Yeah.
How do I go back to the one I was just at? Is it option minus?
Control minus.
Or is it command minus?
Maybe it's command.
No.
I thought it was control minus.
Yeah,
it only does that for the file you.
Oh, okay.
So
Okay.
Alright, so update ID will contain the ID that we want to access, and then we want to access that ID on our hash map.
Where's update ID? Would it just be?
It'll be update.id because update contains a property called ID.
Okay. So in the so update ID. So I'm sorry, I just got caught up on that. So can you say that again when you're over there? I'm sorry.
Update.id is going to contain the ID of the node we want to change.
Mm-hmm.
And that ID is going to be type string.
Mm-hmm.
And we also have a hash map, which contains a bunch of key value pairs.
Okay.
Where the keys are type string.
Uh-huh.
So what we can do is we need to essentially.
When you type in update.id, it will bring that whole object.
Yes.
Okay, not just the ID.
Remember how there's a second way to access the properties on a hash map, and that's using the bracket and then the property name.
Okay.
And our property name in this case is stored in the variable called update.id.
Okay.
So we can literally do this.sigma nodes bracket update.id bracket.
Okay.
Square brackets.
Update.id. Do I need to put that in there somewhere?
Nah, it's not there. End of line 105.
Yeah, this .sigma nodes.
Yeah, and then bracket update.id bracket.
Should I type that in?
Yeah.
Okay.
Yeah. Square.
Yeah.
Yeah, square bracket. And there should not be space between nodes in update. Yeah, so remove the space between nodes and update. There you go. Do you understand how that works?
So this is the so this is an update to the key of the object. So there's this. So this ID represents a key, and the key represents an object.
The key lets you access the
Yes.
value.
Okay. So explain to me what this line of code does again. I'm sorry.
We have a hash called this.sigma nodes.
Yes.
The way you access values from the key value pairs in that hash is by passing in a key.
Yeah. Okay.
Our key has the value of update.id.
Okay. And is this an update because maybe we're updating the state of the...
We're not updating anything. We're just we are going to update something. This line of code is not updating anything.
Okay.
It's literally just fetching one of the values from our hash.
Okay. I think I just am not understanding a little bit. Let's just keep going.
Yeah. All right. So now we have this sigma node object. This is the node that we want to see what the previous children were.
Mm-hmm. Okay. This is the node.
So sigma node is an object and it contains a children property.
Mm-hmm.
We want to look at the children property and then compare it to the children value in the update object.
Okay.
And see if a child's being removed.
Oh, okay.
So we are going to.
Where would the deleted one be? In update?
Yes.
Okay.
No, it won't actually be an update. Update's only going to contain the new value
It will just have to identify the lack of.
Exactly.
Okay.
Yeah.
Or what it has extra.
Yeah. So, we want to so we're going to get a lot of different types of updates coming through our handle update method. Like command click on iType and ID val update. Alright, and then command click on custom store data types. So those are all the types that come through. We can have an update on tree data and all these other things. We only want to perform the logic we're about to perform if the type is of tree data. So let's add an if statement in Sigma Notes Remover.
Okay. Shit.
Sigma Remover.
Okay.
Alright, so we're going to say
underneath this, or
just comment that line out.
This one I'm on?
Yeah, just comment it. Underneath it say if parentheses update.type
lowercase or
lowercase. It shows you the available properties.
Okay.
And then space triple equals.
What's the significance of triple equals?
It checks for equality. So if update.type equals the value we're about to type, it's going to return the value true. So there's a special type of value in programming called true, and there's another special one called false. And
we don't have to go into it.
Values get returned when you're comparing if two things equal each other.
Okay.
So update.type equals control tab over to interface.ts. Alright, click on custom store data types. Alright, so we're going to type custom store data types dot tree underscore data. So go back to Sigma Notes Remover.
Oh, okay.
Just copy that. If triple equals and then paste what's in here.
And then what? Tree underscore data?
Yeah. So if the update is of that type, we are going to call a method, which we haven't written yet, called handle tree update.
Should I go under?
Yeah, but you need squiggle brackets.
Okay.
Open up squiggle bracket,
I'm sorry, I'm hitting caps lock, not shift.
Gotcha.
Okay.
So say this dot handle tree update. And then the handle tree update method, which we haven't written yet, is going to take one argument, and that argument will be update.
So like this?
Yeah. So now either above or below handle update, let's write a method called public handle tree update. Like above the entire method. So like on line 103 or on line 111.
Oh, okay. So it should be what? Handle?
Public handle tree update. Parentheses.
Should it be instead of this?
Exactly, update. And then update's going to have the same type as on the line below. Type ID and update. iType and val. And then create the body of the function by doing parentheses.
Or here.
Open bracket.
Here?
Yeah. And then enter. Alright. Copy line 108 and put on 105.
Why did we comment this out?
Oh, you cannot comment it out.
Okay.
Yeah, we're not going to include on 108 anymore. You can just delete 108.
Oh, okay.
So we want to we want to get the old children value from sigma node. So create a new constant.
Under here?
Yeah, say const old children.
Like that?
Yeah, and then don't type it, no need to type it. Is equal to sigma node, lowercase sigma node, dot children. Yeah. And command mouse over children. I'm curious what type it is. Yeah, it's a string, right? That's what I thought. All right. Now we're going to get the new children. So say const new children is equal to update dot val.
Capital or?
Yeah, just the lowercase. You see how it's lowercase in the autocomplete. Dot children. Okay. Before we do that, on between lines 106 and 107, create a new variable called new tree value. So you const new tree value. Is equal to update.val, and then type new tree value to be
Wait.
tree without ID.
Do you want me to do dot?
Then I'll type new tree value by doing a colon after new tree value.
Oh yeah, okay, right.
Yeah. No, not after new tree value, after the variable name.
Right here.
Yeah.
Okay.
Yeah, colon.
Yeah.
And then I tree data without ID. Data without ID. And then put a space after that colon. Alright. So I just happen to know that all updates that have the update.type property equal to custom sort data types on tree data. I just happen to know, based on the way you wrote the code, that the update.val is going to have the type iTree data without ID. So if you were to command mouse over iTree data without ID, you can see it has three properties. That's what we're talking about. Alright, so change line 109 to new tree value.children.
Wait.
109. Change after the equal sign to new tree value.children.
Okay.
There you go. Alright. So we will know So what we can do is loop. You might remember the concept of for each loop. We're going to loop through each value in the old children array. So yeah, line 107, let's type old children. It's going to be a type string array. Let's explicitly type it. So old children colon.
Okay.
Space string array. Bracket.
Yeah.
Right. Likewise, new children is going to be a type string array. Okay. So we're going to loop through each value in old children, and then see if that old value exists in the new children. If it does not, we're going to call the remove node method for that ID. Alright.
Mm-hmm.
So after line 109, hit enter. Yeah. We're going to say old children dot for each. Yeah. Dot FOR capital E. Yeah. Enter. And then we're going to create something called an anonymous function, which we did a few days ago. So parentheses. So for each takes one argument, and it takes a function. That's an anonymous function. So we'll delete the second parentheses and do another open parentheses. Type. All right. So these are the parameters of our anonymous function. So we're going to type child ID with nice capitalization, and then space colon. Actually, no, my bad, no space. Colon and then space. And we're going to give child ID the type of ID. So just sorry to say ID. Lowercase. Yeah. And we really only need one parameter in the function, so you don't need a comma. Yeah, ID. And then after the hit space and then equal sign greater than arrow. No spaces. Equal sign greater than arrow without a space between.
Wait, like this.
Yeah. And then space, open squiggle bracket, enter. And then at the end of line 112, close off the for each loop with a close parentheses.
Like this?
But after the bracket.
Oh, okay.
Yeah, there we go. All right, so we're calling the dot for each method available on the old children variable. We're passing an anonymous function. That anonymous function has one parameter called child ID. That parameter has a type of ID. And now we're going to write the body of the function. So tab over like 2 times. Yeah, there are, I guess, just once. Backspace. And type remember how we did that index alpha method thing before?
It's an index of. Maybe let's just do it and.
There might be a better method. Hold on, I'm gonna Google something about JavaScript.
Okay.
Okay. So it turns out arrays contain a method called includes. So we're gonna see if new children includes child ID.
Okay.
So includes returns something called a boolean. A boolean will be either true or false. So we're going to say that if
over here.
Yeah, we're going to create a variable called constant. My bad, I shouldn't have said that yet. So you delete that. Const exists in new children.
Like this?
Yeah. Is equal to new children dot includes child ID. So
Space.
parentheses. Yeah, parentheses. And then child ID. To be more explicit with their naming, let's change exists in new children to child exists in new children. So just add child before exists, and then capitalize exists. All right. So does that make any intuitive sense to you? New children will return a value either true or false if child ID is included inside of the new children array.
Okay. Yeah, I get it. Like, so new children
Yeah.
with if there is a child ID in there, it would be true. If it's not, it'd be false.
Exactly.
And then what would happen? Is this me basically saying
And
that
it gets the value either true or false.
this is equal to the true or false?
Yes.
Okay.
So
Do we now have to make this do something or put that
we're
somewhere?
going to use that something.
Yeah.
So now we can create a variable called const child removed. So if the child exists in the new children, then we know that the child was not removed. If the child does not exist in the new children, we know that the child was removed. So child removed is the opposite of child exists in new children.
Mm-hmm.
So we just need set child removed equal to the opposite value of child exists. So child exists is true. We set child removed to false. If child exists is false, we should set child removed equal to true. We could do that by writing a few if statements. There's an easy way to do it, and that's by saying child removed is equal to not child exists in new children. And the word, when we say not in programming, we just write an exclamation mark. So
Okay.
do exclamation mark, and then child exists in new children. Yeah. Yeah, you can just hit enter a lot this week.
Oh.
Alright. If,
Down here?
yeah, so if child removed, with nice parentheses, and you want space before the parentheses. If child removed, that's one word. Yep, and then you close parentheses. And bracket, let's put a bracket. We're going to call, hit on it. We're going to call a method that removes the nodes. And I'm not sure where you're at the method. Let's scroll down to Sigma nodes and remove your args. Alright. Let's hover over iSigma RenderManager. Line 133, command hover over it. Not types, but the actual interface.
Right here?
Well, iSigma RenderManager. Yeah. That's not the one we want. Go to interfaces TFs and look at the interface for RenderManager. There we go. We have a method called remove node. Or command click on iSigma render update on 912. Yeah. Alright, do a command shift F for iSigma render update. Let's open up RenderManager.ts. Yeah. Alright. So RenderManager.ts subscribes to some updates. What is it subscribed to though? Command Shift F for lowercase RenderManager.subscribe.
RenderManager.
Yeah, with a capital M though. Yeah, RenderManager.
That's it.
Yeah, the manager though. That's manager. Which is the typo. Manager. Manager. Yeah, manager dot subscribe. Yeah, enter. So subscribes to Sigma. Alright, we're gonna draw this here again. So we have RenderManager. Sigma.
If you're, I mean, only if you really want to go away. I have food in the Smith fridge.
RenderManager subscribes to Sigma RenderManager.
I'll just do it then.
Yeah. RenderManager subscribes. And subscribes to updates of the type Sigma render update. This syntax right here, that's not valid TypeScript syntax. I'm just writing stuff. Sigma render update. So somehow, from inside of Sigma nodes remover, we need to get Sigma render manager to publish an update.
Inside of Sigma, we need Sigma RenderManager to post an update inside of.
Just for itself to publish an update.
Okay.
And then anything that's subscribing to it, such as this file over here, will subscribe to that update.
Yeah.
And then our update's going to have a property in it called type. And if we set type equal to render updates type.remove node, it'll remove the node for us.
Okay.
So somehow we get Sigma render manager to publish an update with the type remove node. So let's go inside of Sigma render manager.
I see. Okay, Sigma RenderManager.
Yes.
Alright. That's right. So yeah, scroll down a bit. Keep scrolling down. Oh, you'll actually scroll back up. Scroll. Alright, stop there. Okay. So
I'll be very amazed if you remember this. But remember how last week we were talking about this whole callbacks thing, where we had a property called this.callbacks that was an array of callback functions, and we added a function into that list with the .onUpdate method.
I remember doing that.
Yeah, and whenever we called the .receive update method, we essentially called every single callback function inside of this .callbacks.
Okay.
So each of those callbacks are functions, right? Functions can take arguments. The way we're using the subscription and publishing service here is we're going to pass a certain argument into our callback function. And the argument we're passing is whatever is returned from this callback arguments function. So we're going to call all of our callbacks. Does that record audio too?
Yeah.
Oh, that's it. Okay. It's going to record, it's going to call our callback functions with the following argument, and that following argument will be whatever is returned right here.
Okay.
Now, why is there a red underline there? What's that say?
Not assignment iSignaRender update. iSignaRender type array. Let's command click on iSignaRender update. Command click on iSignaRender update for what is this nonsense? Control tab.
To where?
Just whatever was the frick for Sigma Render Manager.
Sigma render.
Yeah, if I say control tab, it just means control tab once.
Yeah,
It's
okay.
active. Oh, it's just because we have the wrong value for Sigma ID. So we want, how does Sigma Render Manager get the ID? Okay. This time. All right, let's scroll to the top. Notice how we just have a bunch of random variables here, like called tree ID to broadcast or edge IDs to broadcast. Let's create another property called tree ID to remove.
Just below anyway.
Let's do it between line 13 and 14. And then give it the type ID. Awesome. And we're going to have to add that as a property inside of our constructor arguments. So add that between line 24 and 25.
Just tree ID to remove.
And then between line 35 and 36, we're also going to have to set the this.tree ID remove to equal, whatever's passing the argument. All right. Now, scroll down all the way. All right, scroll a little bit. Notice how there's a red underline on line 35.
Wait,
25,
35?
25.
Yeah.
Do you know why that is? All right, we'll mouse over it. So what do we need to do?
So we need to make this a property in Sigma Render Manager?
Yeah, RenderManager args. Yeah. Yeah, so just option click on Sigma RenderManager args on line 30. Not types of Sigma RenderManager.
Okay.
The actual interface called Sigma RenderManager args. So
Right here.
option click on 30, yeah. Yeah, so just add that as a property there.
Like just every inject, all that shit. Or no?
Do it actually. I'm really confused. Scroll back up to yeah, scroll up a little more. So up to the constructor. Keep scrolling, keep scrolling, keep scrolling, keep scrolling, keep scrolling, keep scrolling. Alright, stop right there. Notice how you have tree ID to broadcast. Use that. Control F for tree ID to broadcast. The tree ID to broadcast, just the command F for it. Yeah, just hit enter. Let's see all the instances of it. All right, hit enter again. All right, stop. Where is it right now? Oh, it's right there. Okay, that's interesting. So do you notice how tree ID to broadcast we actually did not have in the constructor?
You didn't?
Yeah, it doesn't exist in the constructor. We have edge ID to broadcast. We have no tree ID to broadcast.
So it won't make our app crash, but there's this thing I'm trying to do where if you pass, if any variable you have in your class, like that we define up on lines 10 through 20, if we make it such that we always set the initial value of those variables using the constructor, then theoretically down the road, we'll be able to save the entire state of our app and like cache it offline for someone. So without an online connection, someone will be able to boot up the app.
Oh, really?
Yeah, I didn't explain why it'll be able to do that, but it'll be necessary for doing that.
Yeah.
So we want to add tree ID to broadcast inside of, let's do it above edge IDs to broadcast. So between 23 and 24. Shoot.
Hmm.
Oh, fudge. I totally fucked. Missed the call.
Was it Patrick or was it another client?
Let
URL.
me.
Go ahead, take it. Take it.